countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let us begin our session by reciting a prayer according to our religions. Let me introduce myself. I'm Teacher Tan from College Matriculasi Selangor, the moderator of the day. We at the Pusat Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revisions. So are you ready? Let me introduce our teacher for today's lesson. We have Teacher Gon from College Matriculasi Perak. We are now live on Teacher Gon's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is Louis structure, and together with us, we also have Teacher Vivi Lau from Pusat Tingkatan 6 SMK Tinggi Klang, who is the control host in charge to ensure the smoothness of our lessons on technical support, and Cikgu Shannon from College Matriculasi Pulau Pinang as the observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use the chat sections wisely. Number two, regarding certificate link, the link will be given at the end of our sessions. Please use your eDidik account when you fill in your particulars. And make sure to listen to the passcode given by me throughout the lesson and fill in the form within the time limit, which is 30 minutes. Before starting the class, I shall give you the first two class code, which are A7. A7. So the first two class codes are A7. A7. So without further ado, let's welcome Teacher Kong to start the class.
Hello, good afternoon, everyone. Before we start, I would like to introduce my pre-U team members. First of all, I will introduce my team. Okay, my team is chemistry team, who led by Cikgu Shannon. Okay, Teacher Vivi Lau, Teacher Tang, Cikgu Mawa are my teammates. Okay, next. This is mathematics teams, who led by Teacher Im. Next is biology team, who led by Cikgu Faiza. Then next is physics team, who led by Madam Rosmaya. And this one is economy and account teams, who led by Madam Fizi. So please remember, always stay tuned with us on Sunday, 3:30 p.m. Okay. And then this is my profile. I'm from Perak Matriculation College. I have 10 years experience in teaching chemistry. Okay, so most important, okay, you must subscribe my channel and like and share my channel with your friends. Okay, so today, our topic is chemical bondings. Okay, actually for this topic, there are 5 parts, but today we focus on the first part, which is Lewis structure. Okay, for Lewis structure, okay, it will be divided to 6 subtopics. Okay, for today's lesson, we focus on Lewis symbol, octet rules, and formation of chemical bond. Okay, the other 3 will cover by, maybe you cover by Teacher Vivi Lau or Teacher Tang or Cikgu Shannon. Okay, please stay tuned. Okay, so what is Lewis symbol? Okay, if you still remember, for topic electronic configuration, we have to know how to write the electronic configuration. And based on the electronic configuration, we learn in periodic table. Based on the valence electron, okay, or the outermost shell electrons of an atom, we can identify the group, block, and period. So today we have to continue using this concept, okay, to determine the group of the element. So for example, group 1 have the general formula which is NS1, meaning that it has one valence electron. Group 2, alkali earth metal should be no problem, NS2, 2 valence electron. Okay, next, what is the next? Next is group 13. Always remember, we continue with group 13, not group 3, because group 3 is block B. Okay, we didn't study about it. We study about block S and block P only. So from group 13 until, okay, group 17 or even group 18, right, with the general formula NS2 and P1, okay, the general pattern of the electronic configuration. If NS2 and P1, 3 valence electron, group 3. NS2 and P4, 4 valence electron, group 4, and so on. Okay, I hope you all can understand for this part. Okay, based on the valence electron, right? Okay, we will continue with Lewis dot symbol, meaning that it's the symbol in which dot, sometimes we represent by cross, are used around the atomic symbol of an element represent its valence electron. So for example, okay, we have to base on the electronic configuration if we're not sure the group of the element. Okay, so element in the same group have similar outer electron configuration, and hence it has the similar number of dots. Okay, look at this one. Okay, this one is lead in group 14. That's why there has 4 dots. Okay, we can represent by dot or cross, but normally I will use the cross one. So 1 dot or cross, right, for each valence electron. So group 14, there are 4 valence electrons. So 1, 2, 3, 4. There are 4 dots. Okay, Lewis symbol, Lewis structure, Lewis diagram, Lewis dot symbol, all the same. Okay, so let's try one example. Oxygen. This is the electronic configuration for oxygen because we have to know, right, the proton number of oxygen is 8. So when we write down the electronic configuration, 1s2, 2s2, 2p4. So based on here, right, okay, I show you all, okay. Based on here, we know the highest n is 2. Okay, n equal to 2. So this is outer orbital. Okay, so this one considered as valence electron. 2 plus 4 equal to 6. So there are 6 valence electron. Okay, we know this one is group 16 because block P. Okay, block P we need to add 10. So we know this one is group 16. So the largest n is 2. So the valence orbital are 2s and 2p. So sum up is valence electron equal to 6. That's why you have to draw the 6 dot. So this is the Lewis dot symbol for oxygen. Okay, clear? Okay, let's try another 2 example. Aluminium. Aluminium given the proton number 13, right? So 1s2, 2s2, 2p6, 3s2, 3p1. So based on here, the highest n is equal to 3. So the highest n equal to 3. And then the valence electron is 2 plus 1 equal to 3. So that's why there are 3 dots. So you can write the aluminium, the symbol of aluminium. So 1, 2, 3 dots. Okay, so let's check. Yeah, 1s2. This is orbital diagram. You can represent by using SPDF notation or orbital diagram as well. So number of valence equal to 3. So the symbol is like this. Okay. For nitrogen, 1s2, 2s2. Okay, 4 already, right? So 2p, 3. Am I right? 2, 2, 3. Yeah, 7. So the highest n, okay, this is the valence electron. Why? Because the highest n is n equal to 2. So the number of valence electron equal to 2 plus 3, so equal to 5. So, okay, group 15, I know there are 5 dots. So I have to assign equally here, 1, 2, 3, 4. And then the 5th one is here. So this is the Lewis dot symbol for nitrogen atom. Let's check. Okay, be careful. 3s2, 3p3 also consider, 3p3. So just like what I'm doing. Yeah, 3p3, correct. Okay, it's the same. So always must remember the highest n, okay, consider as the outermost orbital or the valence orbital, and then the valence electron. So we have to consider the S and P as well. So total equal to 5. So this one is the symbol for nitrogen atom. Okay, so meaning that, okay, group 1 have the same general formula, which is NS2. So what is the element for group 1 in period 2? Everybody, do you know? Okay, the answer is lithium. So lithium with 1 dot. Period 3 is sodium. So sodium also with 1 dot. So you can try to continue for others, okay, others group element from group 1 until group 18. Okay, let's check this one. Yeah, this one you can check. Okay, based on here, right? Okay, I will encourage you all, remember the first 20 element. Okay, zoom. Okay, I will try. Okay, so for example, hydrogen with 1 valence electron, lithium with 1 valence electron, sodium with 1 valence electron. Why? Because all of them, right, is under group 1 element. Next, group 2, beryllium and magnesium with 2 dot. Okay, we skip for the blocky element. Then we continue to here. Okay, group 13, boron, aluminium with 3 dot. Carbon, silicon, group 14 with 4 dot. Nitrogen, phosphorus, group 15 with 5 dot. And then oxygen, sulfur, group 16 with 6 dot. Fluorine and chlorine, group 17 with 7 dot. Okay, and then helium, neon, argon, this group considered as noble gas. Okay, so that already achieved duplet, for example, helium, and then others already achieved octet. What is octet? Okay, later we are going to learn about octet. Okay, so always remember when you assign, right, must assign the dot equally. So for example, silicon, you have to assign 1, 2, 3, 4. Okay, and then 5, nitrogen over here. Okay, 6, 7. Okay, must remember, must assign equally. Okay, now we proceed with octet rules. Okay, what is octet rules? Okay, based on my explanation just now, right? Okay, we know, right? Okay, helium, neon, argon, krypton, xenon, radium. Okay, Rn. Okay, what is the name of Rn? Have a check. Okay, so all of this, right, is considered is group 18. Okay, this one is group 18 element. Okay, helium is duplet. Okay, maximum 2 electron, others maximum 8 electron. So group 18 element actually has monoatomic gases. Helium, duplet with 2 valence electron, others with 8 valence electron, which is Ns2 and P6 as the general formula. So consider octet already. The atom of noble gas does not need to bond to others atom, okay, because they're already stable. Okay, now the molecule of polyatomic, right, try to, okay, combine with others atom, right, to achieve the octet. Okay, means 8 electrons surround each atom. Okay, always remember for hydrogen, just duplet. Okay, duplet already achieve the stability. Okay, so how to achieve octet? Okay, in chemistry, removal or adding process also occur in order to make it more stable or perfect. So just now, as I mentioned, have to combine. How to combine? Okay, how to combine to achieve a more stable electronic configuration? Okay, you see there are some tips here. Cation, anion. What is cation? What is anion? Remember? Okay, so the way to achieve octet, right? To try to transfer. How to transfer? Lose or gain electron. Okay, for example, lithium lose electron, fluoride atom gain electron, and then form lithium fluoride. Or sharing of electron. So fluorine atom, okay, lack of 1 electron. This fluorine atom lack of 1 electron as well. They will try to share the electron so that each of them, right, has the octet configuration. Okay, so what is this? Okay, so before, right, we try to learn about how to achieve the stability. Means how two atoms join together to achieve the octet configuration, right? We must know how ion to make become stable. Okay, electron in the valence orbital can be removed or added to form cation or anion, or in order to have stable electronic configuration, due to these 3 reasons. Okay, the first one, noble gas electronic configuration. Second is pseudo-noble gas configuration. Third one is half-filled orbital electronic configuration. So what is noble, pseudo-noble, and half-filled orbital electronic configuration? Let's look at them by one. Okay. Okay, this one suppose is the first one. Okay, noble gas configuration is a stable ion to achieve duplet to octet 8. So they have the valence electronic configuration like this, Ns2np6 after it formed the stable ion. So for example, sodium, okay, the valence is 3s1, the valence electron is 3s1. So it tried to achieve the noble gas configuration by remove the electron. After it's removed the electron, right, it formed the sodium cation. Okay, this is equal to the neon atom as well. Okay, means 1s2, 2p6, 2s2, 2p6 is the electronic configuration for neon ion. So please have a look here at 2s2, 2p6. So this one is the tally with this valence electronic configuration, this general one. Okay, this one is general one. So that's why sodium atom will achieve the octet by using the noble gas configuration. Okay, okay, means after it's removed the one electron, it will get the 2s2, 2p6 electronic configuration, which is under noble gas configuration category. Yeah? Same for fluoride. Fluoride will try to add electron. After add one electron, right, it will become 2s2, 2p6 as well. Okay, so this is what is noble gas configuration. Okay, next, half-filled. Okay, half-filled orbital configuration, right? We focus on d orbital. So the general, okay, the general valence electronic configuration for half-filled orbital configuration, we check if there is ND5 electronic configuration at last one at the outermost orbital, right? Okay, we call it as half-filled orbital configuration. So for example, manganese. Okay, based on the electronic configuration, okay, after you rearrange, right? Okay, after you rearrange, you remove 2 electrons. After remove 2 electrons from the valence shell, means N equal to 4, it will become manganese ion with 2 plus. Okay, and then you check here, 3D5. So manganese atom, right, or manganese element will achieve the octet, okay, under this category, half-filled orbital, which is have the general valence electronic configuration pattern, which is ND5. Same for iron. Iron, you try to remove 3 electrons from the 4s2 and 1 electron from the 3d6, become 3d5. Now 3d5, so this one is the half-filled orbital configuration. Okay, we proceed on the last, stability of ion, which is pseudo-noble gas configuration. So have the completely filled orbital, but not the noble gas configuration, but is Ns2, Np6, Nd10, or Ns2, Np6, Nd10, and F14. So the trademark is here, Ms14 or Nd10. So the example, right, is gallium. Gallium will remove 3 electrons. After remove 3 electrons from the 4s2, 4p1, right? Okay, it will get the general, okay, it will get the N equal to 3 is the outermost shell now. Okay, and then you check Ns2, Np6, Nd10. Yeah, fulfill this one. So gallium element, right, or gallium atom will achieve the stability, right, under pseudo-noble gas configuration. After remove the 3 electron, it will have the general formula, okay, that's exactly same as the Ns2, Np6, Nd10, which is N equal to 3, 3s2, 3p6, 3d10. Okay, copper also doing the same, okay, have the same pattern. So remove 1 electron, right? Yeah, it has 3s2, 3p6, 3d10. So exactly same as the valence electronic configuration for the pseudo-noble gas configuration. Okay, so I hope you all can understand. Okay, the first one is about noble gas with a stable ion in duplet or octet Ns2 and P6. The second one is half-filled d orbital. Normally we focus on the Nd5. Okay, 3d5, 3d5. This is an example for manganese ion and iron ion. Okay, and then the third one is pseudo-noble gas configuration with the general formula Ns2, Np6, Nd10, or Ns2, Np6, Nd10, and F14. Okay, now, okay, how to achieve octet between atoms? So there are 3 methods. Okay, there are 3 ways. The first one is ionic bond. Second one is covalent bond, and then the third one is dative bond. Okay, so let's look at them one by one. What is ionic, what is covalent, and what is dative bond? Okay, you have to know, right, actually, under ionic bond, for ionic bond, right, there is another name we call it as electrovalent bond as well. Okay, for some time, right, the question will straight away ask you, okay, show the formation of ionic bond, but we change, show the formation of electrovalent bond. So you have to know ionic bond equal to electrovalent bond. Okay, wow, This is a comic, okay? It's from Storyboard That, Ionic Bonding Comic Strip. Okay, let's check. This is sodium. Sodium say what? I wish I could get rid of this extra electron. I don't even need it, so useless. But what happened to chlorine? I am so close to having a full valence shell. Okay, meaning that this one I don't want the one. This one I need extra one more. Okay, so what happened? Okay, what happened after the discuss, right? Excuse me, Corinne, I have an idea. I could give you my electron. Okay, and then Corinne said, oh, you are right. I am non-matter and you are matter. So we could become sodium chloride and ionic bond. Yes. Okay, after it donate, it become cation. This one will become anion, and then anion, it have full field orbital already. Just now 7, now become 8. Okay, so the deal, okay, sodium chloride. Okay, they are so happy. Okay, so this is one of the example, okay, for ionic bond, sodium chloride. Okay, based on that comic, you know, right? Ionic bond involved in transferring of electron. Okay, okay, electron transferring. So normally it's the reaction between matter, means group 1, group 2, or group 13 elements, and react with non-matter element from group 15, group 16, and group 17. Okay, matter transfer the electron. So it can attain the stability, means by forming cation. While non-matter, right, will accept the electron to form anion. Between them, right, okay, is electrostatic force between the positive and negative ion. As I said just now, another name we call it as electrovalent bond. Okay, so again, sodium, just take him, please. Okay, I don't want the one electron. Okay, this one don't mind if I do. Okay, I will accept the electron. Okay, so let's look at this is example sodium chloride again. So electron transfer. Okay, after transfer, it form the chief octet, and then chlorine atom accept it, become chloride ion, and then a chief octet. So sodium chloride ionic bond. Okay, you have to know, right, for ionic bond. Okay, these are the few properties of ionic bond: high melting point, high boiling point, normally solid at room temperature, and then soluble in water. Okay, molten ionic compound, for the ionic compound, right, it will conduct electricity because there are free electron move around. Okay, so this is one of the diagram for sodium chloride, like crystal solid diagram. So between the cation sodium plus and the anion chloride ion. So actually, if, later we will check, right, we will learn about how the metal compound, okay, to conduct electric as well. Metal element conduct electric as well. Okay. So here, okay, I think I no need to show the, okay, never mind, I show one more time. The formation of sodium chloride. Okay, first of all, right, we know sodium with 1 valence electron, and then chlorine with 7 valence electron. Okay, so we must show, right, okay, we must show the transfer of electron. Okay, we must show, right, okay, one of the electron from chlorine transfer to here, and then it will form. Okay, after it transform, right, okay, it will form sodium cation. Always remember, must be the charge. And then the chlorine anion, okay, with negative charge. Okay, student always forget about the 8 dot. So please remember, now you have to assign the 8 dot. Okay, for the chloride ion. Okay, so this is the formation of sodium chloride. If magnesium oxide, okay, actually it's the same as well. Magnesium oxide, magnesium with 2 dot, because group 2, right? And then oxygen with 6 dot. Okay, 1, 2, 1, 2. I will show like this. Okay. So now I have to show. Okay, for ionic bond, right, you must show the transferring of the electron. So 1 electron from the magnesium transfer to here, another 1 transfer to here. Okay. So after transfer, what is the next? After transfer, okay, now the magnesium will become Mg2 plus because it removed 2 electron already. And then oxygen, okay, become 2 negative anion because it's received 2 electrons from magnesium ion. So this is the way to, okay, this is the way to form the magnesium oxide from magnesium atom plus oxygen atom. So this one as matter. This is matter. Matter, okay, remove electron to form cation. And then this one is non-matter. Okay, non-matter will receive electron to form the anion, so that both of the atom will achieve octet. Okay, octet. This is 3s2. After that will become 2p6. 2s2, 2p6. Same for here. This one after receive 2 electron, it also with 2s2, 2p6 electronic configuration. Okay. Calcium bromide. Okay, calcium. Okay, calcium with 2 valence electron, and then plus bromine atom with 7 valence electron. Okay. Okay, because there are 2, right? You have to show the 2 bromine atom. Okay, with 7 dot. Okay, now it's the transferring of the electron. I use another color. Okay, so here transfer of electron. Okay, I transfer this one. I transfer to here, and then this one I transfer to here. Okay, so after that, okay, it will form calcium 2 plus ion because it's remove 2 electron. And then please do remember, now involve 2 bromide ion. Okay, so bromide ion, because each of the bromine atom receive 1 electron, right? So that's why the bromine atom will become bromide ion. Okay, please remember the 2. Okay, so this is the way to show the formation of ionic bond for calcium bromide, and then for magnesium oxide, and then for sodium chloride. Okay, always remember. Okay, I just remind you all again. Okay, you must always remember. Okay, you must show the valence electron for the atom, and then must show the arrow to showing the transfer of the electron from matter to non-matter. After transfer the electron, okay, cation with the positive charge, anion with the negative charge. Please to remember all the anion, right, must with 8 dot. If there are more than 1 atom involved, right, please remember must write the 2 or 3 or 4 even whatever. Okay, for the atom, for the ion must write at the front part. If there are more than 1 atom involved. Okay, so this is the formation of ionic bond. Okay, so finish for ionic bond. So now we move on to covalent bond. And then what is covalent bond? Okay, you see, just now transfer, okay, is electron transfer. But this one, the concept is sharing. Okay, if you check right here, I have one. Both of the one electron from the atom, right, they will share. Okay, they share and then combine, become the covalent bond. Okay. Okay, you check this one. What is the example? Didn't mention, right? Okay, but chlorine here, chlorine with 7 valence electron. Okay, here also with 7 valence electron. Okay, this is also another chlorine atom. So they will share the one. Okay, I'm using the red. This one I'm using the blue dot. So when the red and blue dot join together, right? Okay, each of them, right? Okay, you look at here. This one with 8 valence electron. Another chlorine atom also with 8 valence electron. Normally, right? Okay. For covalent is the reaction between non-metal element only. So non-metal with non-metal. So try to share the electron. Okay, can share one. Also can share more than one. Okay, to achieve the octet configuration. Okay, so based on this diagram, we must know the sharing electron. Okay, this is the bonding. We call it as bonding pair electron. If they share, right, this one we call it bonding pair. Okay, share between 2 atom, chlorine atom. This is bonding pair. The rest, right, we call it as lone pair. Okay, we call it as lone pair. This we call it as lone pair. So the sharing between 2 atoms, the bond share between 2 atoms, we call as bonding pair. Our others one we consider as lone pair. 1 lone pair equivalent to 2 electron. Always must know. 1 lone pair equal to 2 electrons, and 1 bonding pair also equal to 2 electrons. 1 bonding pair equal to 2 electrons. 1 lone pair also equal to 2 electrons. This concept is very important when you continue to study about the when you draw the ring structure or calculate the formal charge. Okay, this concept have to correct. 1 bonding pair equal to 2 electrons. 1 lone pair equal to 2 electrons. Okay, before I proceed for the example, right? Okay, maybe we can go for advertisement first. Teacher Tang, am I right?
Okay, so shall we stop for a while for the advertisement?
Yeah. Thank you, Teacher Tang.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Before we continue the class, let me announce the third class code for today. So the third class code is 1. Again, the third class code is 1. The third class code is 1. So shall we let Teacher Cons to continue the class? So Teacher Cons?
Okay, well, yeah, okay. Thank you, Teacher Tang. Welcome back. Okay, so just now I already tell you all right. The formation of covalent bond is the sharing one or more pair of valence electron between the non-metal atom elements only. They try to share their electron to achieve the octet configuration. So this one, right, the sharing of the electron we consider as bonding pair. The rest, right, okay, at the outside one consider as lone pair. Okay, now let's look at the formation of fluorine molecule. Okay, fluorine molecule. Okay, it forms single bond. Why? Because two atoms share a pair of electrons. Okay, if you check, right, okay, this fluorine atom with 7 valence electron, another fluorine atom with 7 valence electron as well. Okay, meaning that they lack of one electron to achieve octet. Okay, what are they going to do? So they will try to share the one electron. Okay, you contribute one, I contribute one. Okay, we share among each others, right, so that we can achieve octet. Here 7, here 7. Okay, once they share, right, now we check. Now with the 8 electrons, okay, for the first fluorine atom. Of course, the second fluorine atom also with 8 electrons, okay, 8 valence electrons. Okay, so this is the Lewis structure of fluorine molecule. Okay, this is what I mentioned, right? Okay, we must know, okay, here, the formation of the bonding between two fluorine atoms considered as bonding pair, it will form a single covalent bond. Okay, the others one, right, all are lone pair. You can represent the bonding, the 2 dot, right, with this single covalent bond. 2 electrons equal to 1 single covalent bond. Okay, so this is the formation of fluorine molecule. The covalent bond formed by fluorine atom plus fluorine atom, and then form the fluorine molecule by covalent bond. And then this one is the single covalent bond. Okay, we try and look at another example, formation of water. Okay, water with 1 valence electron, oxygen with 6 valence electrons, hydrogen, okay, because H2, right, meaning that there are 2 hydrogen atoms. Okay, they will join together, try to share the H and hydrogen, they will try to share the electrons. Okay, they share the electrons so they can achieve octet. So this is the water molecule. Now you check one by one. Okay, yeah, the oxygen atom, right, already have 8 electrons. And then always remember for hydrogen atom, duplet. Okay, so the 2 dot, right, we can represent by one single line. The one single line considered as single covalent bond. Okay, and then these 2, right, considered as lone pair electrons. So there are 2 lone pairs electron for water molecule. Okay, so this is what I explained just now. So I hope you all understand. Okay, then, okay, this also considered as single bond because one single bond. Okay, we have to know the properties of single bond. Okay, a covalent bond formed when 2 atoms share a pair, means one pair of electron, and then represented by the dash between the 2 atoms. Okay, we must know, right, actually the single covalent bond, okay, is made up of a sigma bond as well. Beside water, beside fluorine molecule, HCl and HF hydrogen fluoride and hydrogen chloride also under this category, means it will form single covalent bond, single bond. Got single, right? Of course, there are double as well, right? So let's check for another example. Formation of CO2. Okay, CO2. Okay, here also another example, oxygen. So meaning that what is the special properties of CO2 and oxygen? Let's check. Okay, double bond. Okay, now two atoms share two pairs of electrons. So if you check, right, initially oxygen with 6 valence electron, carbon with 4 valence electron, oxygen with 6 valence electron. Okay, they will do like this. Okay, I better show you. All right, initially it's like this. Initially, okay, oxygen, carbon first. Carbon is 4 dot 1, 2, 3, 4. And then oxygen 1, 2, 3, 4, 5, 6. And then plus, okay, oxygen 1, 2, 3, 4, 5, 6. Okay, when they join together, right? Okay, meaning that okay, okay, we don't need to show any transferring of electron because this is sharing. So we don't need to show anything. I just use it as explanation. So this one, okay, this one, okay, we'll join. Okay, combine with this, for example. Okay, and then this one, okay, will share. Okay, and then this one will share. Okay, this dot one electron will share with the electron of the oxygen 2, same at here as well. Then they will form the CO2 CO2 molecule. Okay, so and then this dot, right? Okay, these two dot can represent by the single line. Okay, so now become 8 electron for the oxygen atom. Initially just 6, not enough. Okay, but after share the electron with carbon atom, right, now become 8. Same for carbon. Okay, carbon also after share, okay, 4 electron. Okay, 2 with oxygen 1. Okay, another 2 with oxygen 2. Now it achieved octet already. So now this one is double bond. So now this considered as double bond. This one considered as double bond, which share 2 pairs of electrons. Okay, so what is the properties of double bond? Double bond form when 2 atoms share 2 electron pairs of electron. And then it will use represent by double dash. So this is double dash. Okay, and then for the double dash, right, okay, it's made up of 1 sigma plus 1 pi bond. So for example, oxygen. Besides CO2, oxygen also the same. Why? Because oxygen 1, 2, 3, 4, 5, 6 plus oxygen 1, 2, 3, 4, 5, 6. Okay, they will share. Okay, means this one will share with this one. I hope you all can see it. Another one is, okay, this one will share with this one. And then form 2 oxygen atom. Okay, they share 2 pairs of electron. So the rest is the same. 1, 2. This is lone pair. Now I'm drawing the lone pair. Okay. So based on here, right? Okay, we know we can transfer the double dot, right? Become O double bond O. Okay, you have to copy the lone pair as well. So that's why oxygen also one of the example of double bond formation. Okay. Next, nitrogen. Okay. After single bond, after double bond, right? Okay, we look at triple bond. Share 3 pairs of electron. Okay, so this is after formation of the nitrogen. Now we can check. Okay, or this one. Okay, we can check, right? Here 8 electron. And N2 also with 8 electrons. Okay, so this one, right, can represent 2 electron equal to 1 bonding. 2 electron equal to 1. That's why total there are 3 bonding. So this is nitrogen triple bond. Actually, the formation also can like this. You can draw 1, 2, 3, 4, 5 because nitrogen group 15. So there are 5 valence electrons. Okay. So you will try to share the electron like this. Okay. So the first one, this one, share with this one, for example. Okay. And then I try to use the different colors to show you all. Okay, and then this one. Okay, share with this one. And okay, sorry. Okay. And then try to use green color. Okay, so the green, so this one share with this one. So that's why after the share, right, it will produce this nitrogen molecule, okay, with octet configuration. Okay, triple bond. So the properties of triple bond, right? Okay, when two atoms share 3 pairs of electrons, okay, it can represent by the triple dash. So this is the triple dash between two atoms. So triple dash, right, actually is made up of 1 sigma plus 2 pi bond. Okay, beside nitrogen molecule, cyanide ion, also one of the example of triple bond. Okay, so this one, okay, cyanide actually is like this, cyanide ion. Okay, we should know this one. Okay, with lone pair. Okay, cyanide ion. Okay, so I straight away show you all the outcome. Okay, the triple bond of cyanide ion. Normally we write like HCN. If HCN, right, if HCN like this. Okay, in this case, this one is single triple. If just cyanide ion, so it will show the triple bond only. Okay, this is a very famous example when you learn about how to draw the Lewis structure, how to draw the molecular geometry, and then how to draw the hybridization diagram as well. So I let it in future. Okay, I left it in future. So now this is the overall. Okay, this is what I explained just now. Single bond, two atoms share 1 pair of electron. So for example, here the single bond. And then double bond, two atoms share 2 pair of electron. So here is the example of double bond. And then triple bond, two atoms share 3 pairs of electrons. So here is the triple bond. Always remember, make sure that each of the atom achieve duplet or octet. So for example, okay, hydrogen still duplet. And then here, oxygen, the terminal will achieve must achieve octet as well. Same for here, this nitrogen and this nitrogen atom, both nitrogen atom achieve octet. They try to achieve octet by sharing the electrons. Can share 1 pair, 2 pair, or 3 pairs. Okay, now we try to compare between single bond, double bond, triple bond in terms of length and strength. Okay, kepanjangan dan kekuatan. Okay, so let's check. If we check, right, okay, the single bond, okay, if we check for the length in nanometer, right, if we compare 0.15, 0.13, 0.12. So based on here, this one is the shortest one. Okay, the length of triple bond is the shortest one. Okay, and then we check for the bond energy in kilojoule per mole. Okay, triple bond, okay, has the strongest, okay, bond energy, EST. Okay, strongest bond energy. So meaning that if you compare in terms of strength, right, okay, single bond is the weakest. Okay, this one is the weakest. Okay, of course, double bond always in the middle, and then triple bond is the strongest. And compare in terms of bond length, triple bond is the shortest. Okay, and then single bond is the longest. Okay, I hope you all can know about this. So this is another example. Okay, these are other few examples to show the triple, single, or double bond length. Okay, this is just reference. So we can check, right? Okay, carbon-carbon triple bond, you check the length. Is compare shortest. This one also shortest compared to the others. And then we check for the single bond. You see single bond 154. Okay, and then this single bond 143. Okay, showing that single bond has the longest is the longest. The length of the single bond is the longest, and length for the triple bond is the shortest. Okay, now we move on to dative bond. What is dative bond? Actually, right, dative bond under covalent bond as well. Okay, of one atom, okay, they are also showing the sharing of electron, but okay, for this case, right, dative bond is found when one atom provides 2 electrons. Just now, covalent bond, the concept is you contribute one, I contribute one, share amount of 2 atoms. But in this case, the sharing is one atom provide 2 electrons, which are then shared with another atom. Okay, we also can call it as coordinate covalent bond as well. And then we have to represent by an arrow from the donor to the acceptor. Okay, but at the same time, right, the receiver must have empty orbital as well. Okay, must have the empty orbital to remove the lone pair electron. Okay, why I say lone pair electron? Because share 2, right? So 2 electron equal to lone pair. Okay, look at here, I feel unstable. There is no electron from here. But don't worry, I can share one of my lone pair electron with you. So water. Water is the famous example to show the dative bond. Okay, donor atom. This is what I'm, as I say, must have lone pair, and then the acceptor must have empty orbital to fill the two lone pair, two electrons. Okay, same property as the normal covalent bond. Okay, so this is the example. Okay, water, H2O. H2O with two lone pair. Okay. Okay, this is the lone pair from the water. Okay, and then H plus, there is no electron at all. So that's why, okay, it share the lone pair with the H plus ion. Okay, so settled already. Actually, this is showing the dative bond already, but better we show, right, the dative bond by using an arrow from the donor to the acceptor. Okay, always remember, because here there is a positive charge, right? That's why when you draw this overall structure, the product, right, must have the positive charge as well. So this is one of the example of dative bond. Okay, there is another example also. This one just now we explained already. Okay, ammonia. Ammonia, there is one lone pair. So it will share the lone pair with the H plus ion or hydroxonium ion. And then, okay, from the donor to the acceptor. Okay, must show the positive as well. Okay, another one is the ammonia with boron chloride. So the lone pair, okay, because you check, this boron haven't achieved object yet. So the lone pair from the nitrogen atom try to donate. Okay, donate. So, okay, again and again, for covalent bond, we no need to show the arrow. Okay, no need. We straight away show the end product. Okay, we straight away show the end product, which is, okay, the lone pair from the nitrogen, okay, donate to boron, and then form the dative bond. Okay, I would encourage you, all right, when you show the dative bond, right, you must label. Okay, must label. So after you show, right, okay, from the donor to the acceptor, and then show it, okay, this is dative bond. Dative bond. Okay, must label, this one is dative bond. Same for here, this one is dative bond. Same for here, this one is dative bond. Please remember, label the dative bond from donor to acceptor. Okay, now we try exercise 1. Yeah, after I explain about the ionic bond, covalent bond, and dative bond, let's try to predict, okay, which of the two mechanism electron transfer or electron sharing, okay, for aluminium chloride and aluminium fluoride. Okay, so student, you can try. What is the bonding for aluminium chloride and aluminium fluoride? Ionic bond, covalent bond, or dative bond? If you check, right, aluminium group 13, chloride group 17, metal, non-metal, fluoride also group 17. So, metal and non-metal by right should be ionic bond. But something special happened for aluminium chloride. Okay, something special happened for aluminium chloride. I want to share an information with you all. Okay, aluminium chloride actually forming covalent bond, even though it's the reaction between metal and non-metal. Okay, but for aluminium fluoride, yes, ionic bond. Why this happened? Okay, if you check, right, okay, the size of chloride ion is larger than fluoride ion. So we will explain, due to the high polarization is aluminium chloride, so it will behave like covalent bond. And then the electronegativity difference, right, between aluminium chloride is 1.5, while the electronegativity for aluminium and fluoride is 2.5. So in general, like, we will talk like this. Okay, the difference of electronegativity, right, okay, between the metal and non-metal, okay, if you check, right, normally we will say must more than, okay, must more than 1.7, then only can form ionic bond. If not, like for example, the aluminium and chloride, okay, the electronegativity difference just 1.5, that's why it form covalent bond. So meaning that for this one, I will draw like this, with 3 electron plus 7 valence electron on the chlorine atom. Okay, chlorine atom. Okay, actually, you no need to show one by one. You can represent by its 3 chlorine also is okay. So I make it easier. Okay, since I draw okay, no need to draw like me. Okay, class. Okay, make it easier. Okay. Okay, I can straight away show like this. Okay, there are 3 chlorine atoms. Okay, and then form Al, Share the bond, aluminium chloride. How to form the aluminium chloride? Oh, what happened to Madam Kong? Suddenly start how to draw the covalent bond. Okay, how to draw the covalent bond? Share, right? Okay, yeah, we have to share. Okay, so Cl3 are straight away AlCl3. And then must show the, okay, AlCl3. Oh, just straight away AlCl3. Am I right? I suddenly start how to draw the covalent bond. Okay, we move on to aluminium chloride first. Aluminium, okay. Okay, I like to draw the ionic bond. Okay, I like to show the sharing of electron. Okay. Ding, 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 ding. Ding, 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 ding. Okay. Okay, this is special case. I try to pick these two examples for you all. So you all can notice, right? Not all the metal and non-metal can form ionic bond. Okay, so I show the transferring of electron here, transfer electron here, transfer of electron here, and then I show aluminium 3+, aluminium 3+ because you already donate transfer 3 electron to chloride ion. So now there are 3 chloride ion must with 8 dot. Okay, with negative ion. Okay, so this is the formation of ionic bond for aluminium chloride. So what happened to aluminium chloride? Aluminium chloride, I need to show the valence electron, and then I form the aluminium chloride. Aluminium chloride. So AlCl3. Teacher Tang, Cikgu Shanun, and Teacher Vivi Lau. Is it like this? That's all right for covalent bond. What else I need to draw for the aluminium chloride bonding? Aluminium 3 chloride.
Maybe you can draw the electron sharing.
Electron sharing. Oh yeah, electron sharing. So better draw like this. Share among 3, right? So
Yeah.
I just need to show Cl like this with a bracket. But there are 3, right? Cl3, AlCl3. Suddenly I start how to draw it. So for example, chloride just now is like this.
Draw 3 Cl.
So,
Yeah, 3
sorry?
Cl. 3
3
Cl.
Cl here, right? Here
Yeah,
or
yeah.
here?
So
correct, right? 3 in front, right?
yeah.
Have to roll out the 3 Cl atoms.
Yeah, draw all the 3 Cl atom and then each share one pair of electrons.
So better draw out 3, right?
Yeah.
You still got how many minutes? Oh, what? Okay, still got
Oh,
time.
we still have
Wait.
8 minutes. Yeah, 7 minutes.
8 minutes. Okay,
Yeah.
it's enough time. Okay. So so show here aluminium Cl. Ding, ding. Yeah, like this. Yeah. Okay, don't be nervous. You have to continue. Sometimes, right, when you feel nervous, right, you cannot do anything. So you just proceed. The formation of aluminium chloride is like this. Okay. So ugly, this diagram, but I hope you all can see it, right? So when the formation between aluminium and chloride, right? Okay, chloride, there are 3 chloride with 7 valence electron. The chlorine atom with 7 valence electron. You show the bonding. Okay, one of the electron here, right? Okay, share with one of the electron of the chlorine. Of course, you have to show 3. Okay, if you show 3, you'll notice. Okay, this is the blue one. Okay, if I try to draw another one, okay, 1, 2, 3, 4, 5, 6, 7. So I show it by green color. Okay, so meaning that now I'm sharing this one with this one. Okay, and then here, showing the green color. Okay, then I have to draw another one, okay, to show you all how to form the covalent bond between aluminium and chloride. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, red with red. So this is a red one. This is the formation of covalent bond between aluminium atom and chloride atom. Okay, so this is the formation of covalent bond. So you all can see, right, the difference between covalent bond and ionic bond. Ionic bond, you need to show the transfer of electron. And then after transfer of electron, must show the positive charge. After receive, the electron must show the negative charge, and then make sure the N ion with the 8 dot. Okay, since there are 3 fluorine atoms, right, three must right here. And then for covalent bond, you have to show the sharing. Okay, show the sharing of the electron. Okay, of course you no need to show like Madam Kong for the blue, red, or green circle. No need. You just straight away to show the aluminium with 3 dot, and then the chlorine atom, you can straight away show 3 chlorine atom with 7 valence electron. If you want to show by one, and then you no need to show the 3, you can show 1, 2, 3, up to you. Okay, you can straight away show 3 chlorine atom, and then the formation is like this. Okay, one of the electron from the chlorine share the electron with the aluminium atom and then form one bonding. So this one is covalent bond. Same for here, covalent bond, covalent bond. Okay, so we are going to learn how to draw the Lewis structure for aluminium chloride in next lesson as well. Okay, always remember, even though aluminium and chlorine is the reaction between metal or non-metal, due to the electronegativity difference is less than is around 1.5, means which less than 1.7, right? Okay, it will consider as covalent bond. But fluorine is the most electronegative atom for sure. Okay, the difference of the electronegativity more than 1.7, which is 2.5. So this one is ionic bond. Okay, let's try this exercise. Exercise 2, objective question. After we go for exercise 1, is a heavy topic, right? We go for exercise 2. What is the answer for exercise 2? The basic principle formation of electrovalent bond. Always remember, electrovalent bond is same as ionic bond. So what is the answer? Hi students, let's try exercise 2. I give you around 20 seconds and try. Which is the answer? Ionic bond, right? Is it sharing? Transfer? Maybe. Positive ion? Negative charge? Generation of instant Okay, we didn't learn about this. So impossible. So between B and C, which one is the answer? Okay. Okay, students try. Question, exercise 1. Actually, exercise 2. The first objective question. Anyone? I give you some hints already out 2 options. So remain B and C. Which one is the answer?
Chai Zhi say B.
B? Is it? Okay, the answer is, yeah, thank you. You get the correct answer. Congratulations. The transfer of electron, which leads to the formation of ion. But seems like, okay. Okay, it's quite confusing between B and C, but you get the correct answer. Well done. Okay, next question, exercise 3. The electronic configuration of element P and Q. So P, okay, some hints for you all. P3S2. So I know this is group 2. Group 2 metal. 3S2, 3P5. This one is group 17, non-metal. Okay, this one in general. So when P and Q combine to form a compound, determine the most possible formula. Okay, I know this one will form P2 positive because try to achieve octet by remove 2 electrons. And then so try to attain octet by adding 2 electrons, so then Q negative. Okay, and then between metal and non-metal, so I know this is ionic bond. Okay. So option A and B out. Okay, so the type of bonding, I tell you already. And then formula type of bonding. So when P2 plus ion combine with Q negative ion, what is the molecular formula? So what is the answer? Okay. Remain C and D. Which one is the answer? Okay, I give you around 20 seconds. So I think you all should know, right? Because this one you learned already in secondary school. P2 positive when react with the Q negative anion, right? So if we must balance it. So P.
Okay. Zhi Chai say C.
Yeah, yes, well done. The answer is C, PQ2. Okay, so this is the molecular formula when the P react with Q, and then this is one of the ionic bond or electrovalent bond. Okay, next. For the formation of ionic bond between 2 atoms. Okay, so Okay, the option 1, the difference in their electronegativity must be large. I think yes, I did tell you all just now. One of the atom must be a metal, yes, while another must be non-metal, yes. Each atom must achieve octet. Yes, this is the purpose. When two atoms join together, okay, must achieve octet. So the answer is 1, 2, 3. Okay, that's all for today's lesson. Please do remember, stay tuned with us on every Sunday, 3:30 to 4:30. Okay, Cikgu Shanun, Cikgu Vilau, Cikgu Mama, and Cikgu Tang will share our knowledge with you all. Okay, so please remember, subscribe my channel and like and share all the video that you like. Okay, thank you very much.
With God's grace, we are done with today's session. We have learned a lot from Teacher Gon on Louis structure. Congratulations to those who are able to follow our sessions from the beginning until the end. And thank you very much, Teacher Gon, for such an interesting lesson. Before I provide the certificate link, let me give you the last two class codes, which are 6, 7. The last two class codes are 6, 7. So the last two class codes are 6 and 7. Now, please off the live chat button and click subscribe button if you haven't. This is to show your appreciations to Teacher Gon for giving you a free lesson today. Don't forget to also click the bell button so that you won't miss any new videos and live classes from Teacher Gon. If you like today's class, then please click like and share it with your social media friends. Let's share the knowledge you received today. Sharing is caring. When you have finished, type down in the chat session, then I will give you the certificate link. Once again, I would like to thank you, Teacher Gon, for the interesting lesson. Thank you also to Teacher Vivi Lau and Cikgu Shannon for being with us today. I think that's all for now. See you in another session. Please do remember, stay at home. Goodbye, everyone, and have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.